I know. That was my favorite. That was that made my Monday.
Actually, never mind. I forget anything.
The second derivative test. Cavity. All right, let's suppose I have a function h of x. And I would like to know, whoa, Treat Tuesday. I know. Way to go out on a limb there. Obviously, you didn't pick up on the subtle hint of the homemade cake unit circle thing.
Yeah.
So we each get one Oreo, basically.
Okay, so let's suppose we have a function h of x, and I would like to know where that function is increasing and decreasing. How would I do that, Abby?
Okay, wait. What was the question?
I have a function h of x. I'd
Okay.
like to know where h of x is increasing and decreasing.
Find the derivative,
Perfect.
then set it equal to 0 to get the critical numbers,
Perfect.
and then put it on the number line and test.
Let's give it up, huh? Part 2 of that question, Abby. Suppose I have a function g prime of x, and I want to know where g prime of x is increasing and decreasing. How would I do that?
Just take the double prime. Yeah,
Keep going
alright, and then set it equal to 0 and do the same thing.
and do all that other business. So it doesn't matter what function we're starting with. If we want to know where a function is increasing or decreasing, take the derivative, set it equal to 0, number line, test region, done. So whether we call it the first derivative or h of x or g prime of x or q triple prime of x, you do the same thing. Take the derivative, set it equal to 0, test regions. Question?
Won't most of the derivatives, the first derivatives, if they're increasing, won't their second derivatives most likely be increasing?
Not necessarily.
Not necessarily.
That's what we're going to learn about today.
Wait, but how do you know that like they didn't already do the first step and take like the prime of g of x?
Correct. Or, yeah, prime, g prime. Because the problem will specifically say where is, so two different questions. Where is f of x increasing or decreasing? They would ask it that way, so then you know you have to take the derivative. But what we're going to look at today is, I would like to know where f prime is increasing and decreasing. So then I have to, so in order to do this, I have to find f prime. In order to do this, I have to find f double prime.
Okay, so if the
Okay.
problem starts out with prime and you have to.
Correct. And the point being, I don't care what we start with. H of x, g prime of x, f double prime, it doesn't matter. Whatever you want to call that function, we follow that same procedure over and again. Because what happens is people have a tendency to think, well, if I want to know where f prime of x is increasing or decreasing, I already have the derivative, so I just find, no. It's the function that we're starting with, whether it's increasing and decreasing. And that has a direct impact on what we're going to do today with something called concavity. We're not going to get through this whole thing. We probably won't get to the second derivative test because I want to just talk a little bit about concavity and then take a look at homework from the last 2 days. Cam?
Can you go backwards? Like, well, from the derivative,
Thanks, Sam.
can you find out where the first derivative is increasing and decreasing from the second derivative?
That's our third topic.
Okay.
That's integrals. Integrals
Oh,
allow
yeah,
you to go
yeah.
backwards. So, yeah, we're going to do something called concavity, which is concave up and concave down. Then we're going to talk about a point of inflection. That's exciting stuff. And then we'll learn about second derivative test. Second derivative test does exactly what the first derivative test does. It just does it in a different way. And then I don't remember what I put in here. Oh, roll your tongue. No, not that. Roll your tongue. That way. Like that. I can't do it. The U thing. That thing. Right. I can't do that. Stop it! Oh God! Don't ever do that again. What the hell was that?
Lexi did it.
Lexi did it. Oh.
I've seen that. You make
It's
it
It's
I can do that.
Turn your tongue over. I can do that
I
too.
can't turn it.
Just to read.
You can't turn your tongue over?
No.
You can do that weird thing with your tongue.
How do you turn your tongue
Oh, she's got warm in here. Well, yeah, that was wrong. Okay, so f f is differentiable, meaning we can take the derivative on an open interval. Okay, so we're including the endpoints. It's concave up on the interval if f prime is increasing. So we're going to start with a discussion of how concavity relates to f prime, but eventually we're going to get to the second derivative, and that's a little bit easier. Okay. This is also easier to see if I draw you a picture. Concave up. That's concave up. This, concave down. But there's two other scenarios. Whoa. Now you get the idea. What's the difference between all of those?
The direction.
Positive and negative.
Be more specific, Cameron. What's positive? What's negative?
Well, on the left side, it increases to the right, so it's going positive in the x direction as it's going negative.
Wait. Hold on. You're starting with this one?
Yeah.
Okay,
Positive.
what about that? Is it
Positive.
concave up or down?
Neither.
It's concave up.
It's concave up. Okay.
Think about concave up is like a bowl. It'll hold water. Concave down is like
An upside
an
down.
upside down bowl. Won't hold water. Spill cereal all over the counter. This is concave up, and also, what were you saying, Cam?
A positive, or, well, the tangent line would have a negative slope.
Meaning it's decreasing.
It's decreasing.
Right. So this is concave up, but decreasing. What about this guy?
Concave down, but increasing.
Concave down, increasing. This one?
Concave up, increasing. And then concave down.
Okay, 4 possibilities. How do we get these? How do we know if a function is increasing or decreasing?
Still with the tangent.
Keep going.
If it's positive or negative.
Well, it's the stuff we've been doing for the last 2 days, right?
Yeah.
Take the derivative, set it equal to 0. So these things will be determined by the derivative. The concave up and concave down requires a little bit more work. And this definition I'm not real wild about because they talk about this instead of going right to the second derivative. F prime increasing or F prime decreasing. And that's why I started the discussion with what I did, the way I did, I should say, is that if I want to know where F prime is decreasing, as Abby said, you have to take the derivative of F prime, which is F double prime, and then figure out where it's positive and where it's negative. Another way of saying this is where F double prime is greater than 0. Does that make sense? Yes or no? Because you would take the derivative of F prime to get F double prime, find the critical numbers, test regions, and where the regions are positive would mean that it's increasing. This would be the same thing as where F double prime is less than 0. And this is eventually working towards that concept that I talked about earlier about doing some really nice graphs. Because you can think about doing a graph, just because you know the graph is increasing doesn't necessarily mean it's going to look like an upside down parabola. It could be actually curving up like this one. So these are both increasing, they just have different shapes. This will hold water like a bowl, this won't. Same thing is true with decreasing. It could be concave up or concave down. So we throw another element into the stuff that we're going to be talking about. Are we good here? So concave up, increasing, we did this already, so it's just pictures. All right, and that's what I just said. Okay, so testing for a concavity. The theory is great, the definition is fantastic, but this is what's really going to work for us. We're going to look at where is F double prime greater than 0? Okay, concave up, where is F double prime less than 0, concave down. And we add that as another element to what we're doing. So we start with the function, we take the derivative, we find the critical numbers, we test them on a first derivative number line. Then we take the second derivative, find the critical numbers of the second derivative, put those on a second derivative number line, test regions. This will be fun.
Doesn't work. It doesn't.
Double prime?
F double prime.
Okay.
It won't work for linear functions, right?
Well, you tell me. What happens when you take the derivative of a linear function?
You get a constant and then you get 0.
Ooh, that was horrible. Let me try that again. That's not much better.
That's
Concave up or concave down?
Neither.
Neither.
Or both.
Whoa. Does a circle have no edges or infinite edges? Chicken or egg?
I don't like that.
I don't care.
Chicken.
What does,
Let's avoid it by not talking about it.
what does AP say?
I'm sorry?
What does AP say?
It's actually
Do they
Chicken. They go with the chicken all the time.
Chicken.
Chicken.
So
Yeah, so if that question shows up on the AP test, chicken or egg, always go with chicken.
Just write chicken.
no, better get
raw chicken.
Okay, so here we go. We've got a nice little parabola. No, not parabola, I lied. Cubic. And we'd like to know where it's concave up and concave down. So the process is just like we've already talked about. We need f prime first. Alex, your turn. F prime.
3x squared plus 2x minus 5.
Well done. Since it's not asking in it, I think I just hit a stroke.
Toast?
Since it since it's not asking us anything about where the function is increasing or decreasing, we're going to skip the critical numbers of all this gunk and go right to f double prime. Alex, back to you. You started this mess.
6x plus 2.
Well done. Therefore, Alex, the critical numbers would be where x is equal to 1/3. Okay. Nope. Yep. Good. Because that's where it equals.
it's negative.
Oh, you sure?
Yes. Oh, yeah.
Yeah. Okay. I knew we'd get there eventually. With some help from the rest of you. Now it's negative. Second derivative number line. Oh, look. Second derivative number line. Label your number lines. And graph your points in the correct numerical order.
There's only one point.
Mary? Excuse me, Mary. Special time in my life. What number would you like to test over here? -1. You're a mad woman. Where am I going to test that -1?
Or double prime.
F double prime. So if I put -1 in here, do I get a positive or negative value? Negative. Unlike the other number line, this is now concave down.
Why'd you take 2 derivatives?
Oh my god.
Where you been, Sam? You take a nap before? Go to your happy place? Mary, what number would you like to choose over here?
0.
0's a good call. What do you get?
Positive.
Positive.
So wait, how would you determine concave down? Because it's negative? What the second one's decreasing?
Where the second derivative is positive is concave up. Where the second derivative is negative is concave down.
Are there... Okay, so, and then to get concave up and down increasing, you have to go back to the first derivatives?
No, just to find out where it's increasing and decreasing.
Okay, so then how do you find out if concave up or concave down is increasing or decreasing?
It's not. You can't. It doesn't make any sense. You get increasing and decreasing, concave up and concave down, and then you put them together.
Oh, okay.
Because if we were to go back here and find the critical numbers, then I'd have a
That
first
can
derivative
decrease
number
and
line.
increase.
I have increasing and decreasing from that, and then I match it up with the critical. Does this make sense? Well, this is a cubic, and most cubics are going to look something like that. That's a pretty good cubic.
You should save that.
It's not that big of a deal. I've done better. What's special? Ooh, come on now. What's special about that point? Horizontal tangent? Not a bad guess. No, that's not correct.
Okay.
Vertical tangent, also a good guess. Not correct.
Midpoint.
Midpoint of an infinite function?
The secant point.
Okay.
Is it the point in between the curve down and curve up?
Concave up, concave down.
Yeah, that.
Yeah. Yeah. Where is that point? X equals?
Negative 1/3.
What?
What just happened to the thickness?
I don't know how that happened.
You clicked on a smaller.
The slim.
No, I clicked on red.
Then you clicked on a smaller one.
Oh.
But the
Susan
cubic,
saw this
was this.
happening.
Oh wait, no, you drew the dot.
Whoa.
Oh.
I feel like a tagger now. That happens at x equals negative 1/3, which is our critical number. And that's a pretty important point, because notice on the graph, I don't know how this is going to work out. Oh, there we go. Concave down up to that point. Concave up from that point on. That point that we just found, that critical number, is called the point of inflection.
Cool.
Point of inflection, and I think that's on one of the upcoming slides, but I jumped the gun while we have that picture.
That will always be a critical number.
I hesitate to use words like always and never, but for the most part, points of inflection will be critical numbers. Oh, probably did all the work here. Just okay. Yeah. Come on.
So do you have to find the critical numbers for f prime first?
No, I was just feeling saucy when I made my answer key. So
Will
Yeah.
we have to at some point?
at some point, yeah, because we're gonna put all this together into one big happy little graph.
Take pictures with them.
Let's try this one, shall we? Oh, yes.
Whoa!
Whoa.
So we're gonna be okay. Everybody take a breath. Before we get started, this is our first rational function. The last one we did was a polynomial. Polynomials have, they're continuous and they're differentiable. This is a rational function. Before we start anything, what can't x be?
Square root of 3. Or negative.
X cannot be plus or minus the square root of 3. We're going to keep that in mind because it might pop up later.
Well, it could
Well, no, it won't because it's a squared function, so it's just going to be positive regardless.
So it can't be square root of 3?
It can be.
It can be,
Yeah.
as in
But
tin.
it can, yeah.
Tin can be.
If it really wants to.
So there's no critical numbers from the bottom there?
No, because when you
There's
square
nothing
it-
I can put in for x that's going to make that 0.
Negative 3 and the square root.
We don't
Oh, look at you.
Yeah, what about imagine? I got it.
Yeah, we could go imaginary, but no.
There's no real numbers that will give you it.
No, I'm not in the mood for that.
Oh, yes.
All right. What's f prime? Go ahead. It's good for you. Builds character. Well, you can do a quotient rule. You can do it as product rule. You can incorporate the 6 into it. You can leave the 6 sitting out front. That, that's what makes it such a great country.
But the French don't have this.
No, the French have to do the quotient rule. Have to do this stupid quotient rule again. I hate it. Why can't we do the product rule like the Americans? Are the Frenchies still here, by the way? Who's got a Frenchie at home?
I think
They left last.
They leave tomorrow. Okay.
The Spaniards are close.
Oh, joy! Spaniards are coming. The Spaniards are coming.
They come out in November.
Yeah,
Yeah, they come the first week.
It's almost November, isn't it?
Yeah, it's like 8 days from home. Hey, don't
As
say
a-
November.
7 days.
Don't what?
Don't say November. I got a 6th grade.
What?
Like in 8 days.
What happens in November 1st?
Our
Oh
expectations
boy,
are-
I forgot.
Yeah.
Holy guacamole.
My sister's like, why did you have
Alright,
to
now
say
the
no?
class
It's
won't be able to
because
settle
how
down.
When did the Italians come? They already did. Oh.
Italian in the style.
I know uniform.
When? On the day we had that sub.
For I don't remember.
Oh.
I'm a legend.
Yeah, I did remember you were present. Because my Italian said, see.
So I can get in.
Where are you getting that negative?
Sorry, I wish.
Magic?
Pretty much because he's more.
You got the same thing, right?
Yeah.
Good. Critical numbers. Oh wait, we don't care about critical numbers here. We're not doing the increase and decrease. We'll skip that part.
Well, like, is it just?
Let's just go right to the second derivative.
Oh yeah.
Oh,
I'm gonna change colors.
big meaty.
Oh, there's gonna be.
Wait, that's cheesy, right?
Oh yeah, there's a fat quotient change on this.
I don't know what to figure of that sentence.
Oh boy, here we go. Yeah, real long Gazinta bar for that one. Not gonna have enough room. Take one out of there. Negative 12. All right, hold on. Continued on next line.
I got that.
So you want to do the product?
It's an ugly change regardless.
4x.
No.
No.
No. Don't call it.
Can this not be on this
This
one?
isn't that hard. Like that's
I heard that.
That's disgusting.
I'm just asking.
This isn't good. Why you multiplying
Or exactly, just kidding.
Our ancestors. No, the pioneers.
Oh, that's not so bad.
Are you
Come
kidding?
on.
Wait, Mr. Reedy,
Huh?
the
What
negative
is the power
12
down there?
from the
13?
first part of the product thing,
Huh.
where did you put it in the second one? Did you already like factor it out though?
Where, this guy?
Yeah,
Where'd that go?
where'd he go?
That, when I pulled out the x squared plus 3, I pulled out one of those. I distributed that to the x squared. That's where the 36 came from too. Negative 36.
Well, why is that one over there then? Oh, I see, never mind.
Well, it's under there.
No,
Under where?
I see it. You just like,
This is a little hard to read, but if we bring it up here, I've got negative 12 times, oh, green is cool. Negative 12 times x squared minus 4x plus 3 all over x squared plus 3 to the third power. That's not going to give us anything because we already talked about that. You can't make that 0. But I'll get two critical numbers from this puppy because that factors into x minus 3 and x minus 1. So therefore, my critical numbers from the second derivative would be x equals 3 and 1.
Interesting.
That was fun, wasn't it?
Yep.
No,
Now
did-
plug
well,
it back
that's-
in.
I have a question.
Yo,
That's not what it says on your spreadsheet.
what?
Yeah.
Ooh.
wait, on the
So what?
on the
We got
second
F
right,
prime,
it's,
but not F
twelve
double
x
prime.
squared.
So minus 4 is to negative 3.
Should've done
Factored
the
out
product
negative
rule.
3 minus 4. Shut up, Sam. She's in manual. That was me mocking you. What's it say in there?
36 times x squared minus 1 over x squared plus 3 to the third.
What?
You forgot to multiply the 3, I think.
What 3?
There's two numbers.
3.
From the.
Okay.
The 2 in front of the x
Oh, yeah,
squared
the
plus
2, not the
3.
3. It should be 24, shouldn't it?
In the table.
What should be 24?
In front of the. Well, when you multiply the second term, the negative 12x times 2 times 2. Oh, wait.
No, that's 48x squared.
Yeah, that's 48x.
Okay.
Should it be 48x squared, not just 48x?
Oh.
If only we had the product.
Oh wait, I got it.
Product rule would have been so much
Oh wait,
fun.
Yeah,
wouldn't it be
No,
like
that's
x
why you do the
power
Took that
x
out,
squared?
so
You're
that's,
doing
Just simplify.
48x squared times x squared plus 3.
that's 4 times 12 is that's positive 48. It should, I think, yeah, that's where I screwed up. This should be x squared, I think.
Yeah, because you have it right
Yeah.
up until there,
Yeah,
and then you
yeah.
have a different answer.
That's all right, I got an eraser. That's why we make erasers. I can fix it.
Wait, so is that negative, in the one where you just corrected, is that negative 12x to the third then?
No, to the second.
Okay, just one second.
That's the worst part, is when you get told you're wrong by your own work. Thanks, Lexi.
Sorry, my bad.
Go see the dog after that. Okay, so then, let me try that again. So the x squared plus 3 over that'll cancel, so I know on the bottom I have x squared plus 3 to the third power. Then on the top I would have, if I take out the negative 12, no, that's take out a 36, that's where I got it. Oh, okay, I'm
How can you do that? Wait, what?
because this will be 36x squared, so it'll be x minus 1.
Oh,
How'd I do?
yeah, that's x squared plus minus 1.
X squared minus, right.
Yeah, okay.
I know, I was just seeing if you're paying attention, good job.
Right.
Is that
Yeah,
good?
That's what you're
Mr. Reedy,
Yeah.
when you take out one of the x squared plus 3's, why don't you take one out from the bottom? Or do you?
He did.
I did, I canceled, that's how this became a tree. I canceled this
Yeah.
with that.
Oh, so you didn't multiply out. Okay.
F double prime, negative 1, 1. Put in a big honking negative number there. Well, if I put in a big honking negative number, this top is going to be positive over the bottom always being positive, positive. So that's concave up. Put in 0, that's going to be, negative over positive is negative, concave down, and then put in a big honking number, that'll be positive, concave up. There we go. And then you do, some interval notation there, negative infinity to negative 1, and 1 to infinity for concave up, and then concave down would be 1, negative
Yeah,
1
how
and
do you
1.
how do you notate that?
so
Like,
there's-
How do you what?
do you just write CU in front of brackets and then
Oh, I see what you're saying. Yeah, you could,
yeah.
And so there's 2 points of interest in this one.
Yep.
Okay.
And both of those points are what we call points of inflection because it's changing.
That's what I meant with inflection, not interest.
However, it is possible that you get a number line, like the ones we've looked at before, where it goes concave up, concave down. Let's suppose this is at negative 4 and this is at 2. This would not be a point of inflection. This one, however, would be. Okay, so you'll see the other problems where you're asked to find the points of inflection. It's just a further step past here. Okay. That was fun. I'm erasing now, is that okay? I've already got the work in here, don't I? I am so dumb. It's good for me, it keeps me honest. All right, we'll stop there. We already know what a point of inflection is, but we'll pick up where we left off with this, mañana. That's Spanish for tomorrow.
Or morning.